Everyone check the things about Joule's law we discussed. Joule's law we discussed. So today we have to continue further topics of this one. So in last class we discussed about Joule's law beta. Some applications and everything we discussed, and we have to go ahead. Now this week from my track, nothing is there. What I am teaching, nothing will come from thermodynamics. So previous week topics only, just to go through once, it's enough. And coming to this topic this week, we already discussed about Joule's law, some applications. We'll discuss one more application. I have sent the notes also to you people. So in that one, here we discussed about a few applications, and let us see the remaining applications. Please concentrate better. Very important. Each and every application is one problem. So you need to pay attention and you have to practice them. So switch off your videos and everything. Now coming to next applications. Here whenever we are firing, suppose one beautiful application is like that. So from one gun a bullet is fired. From the gun a bullet of mass small m is fired. Is moving with a speed v and hits the target. So it hits the target. Joule's law application. We are discussing yesterday's continuation, Joule's law application. So target. So when it hits the target, what will happen? Heat is generated. So here what happened means, one thing we can say, bullet is traveling and hitting. This is a beautiful bullet. And this bullet is going and hitting, and fire bullet is moving and hitting the target. So the heat generated by this heat, when it hits the target, the heat is equally divided for the total heat. Whatever produced in the collision. So this is the first one, this is the first page. This is about application of Joule's law, continuation to last class. I hope you people are there for last class beta. Continuation topics to last class. So the total heat, this one application here. So the bullet hits the target. Please concentrate. Bullet hits the target. When bullet hits the target, we will get heat energy is produced. The total heat produced is equally shared between bullet and target. It is equally shared. Equal amount of heat is given to both bullet and target. That is, now bullet is having this total heat. Suppose I am calling it as Q. So total heat I am calling it as Q now. So this will become Q by 2. So this target also will have the heat energy Q by 2. So they are given in the question like that. They have given that. So the bullet hits the target. After hitting the target, the heat is equally shared between bullet and target. So it is equally shared between bullet and target. So both are getting q by 2, q by 2. Now the question is, find rise in temperature of bullet. Find rise in temperature of bullet. Beta, we are running according to the schedule. Thermal properties of matter totally it is not completed. Some parts, conduction, that is transmission of heat, conduction, convection, radiation, they asked us to complete the topic after thermodynamics and KTG, gases and KTG. So now we are going with this topic beta. Please concentrate. Find rise of temperature of the bullet. So here what happened? A bullet of mass m moving with a speed v hits the target and the heat is generated is equally shared between these two, equally shared, and because of that what is the rise of temperature of bullet? Rise of temperature of bullet. First of all, that heat energy is nothing but W is equal to, we can write JQ. W is equal to JQ. If everything is in SI system, if total I am taking in SI system, simply I can write W is equal to Q. Take Q in SI system, W also in SI system. Directly I can write W is equal to Q. Understand or not? W is equal to Q. Here this what is the work here means moving body. Moving body has kinetic energy. The moving body in horizontal line is not above the ground. That means we take only kinetic energy here. Only kinetic energy of mv square. It is moving in horizontal of mv square. This is converted to heat energy. And heat energy, Q is the heat energy it obtained of mv square is equal to Q. This Q is given to again, this Q is given to what? Bullet and target. Bullet and target equally. Bullet and target equally. Just now we told bullet takes Q by 2, target takes Q by 2. So they are asking temperature rise of bullet. Temperature rise of bullet. So by taking this heat energy Q by T, the bullet temperature rise. Sir, how W will be half mv square? Generally, what is W? Mechanical work done. Mechanical work done means we will be taking either potential energy or kinetic energy. Potential energy or kinetic energy or kinetic energy plus potential energy. Kinetic energy plus potential energy. Kinetic energy plus potential energy. Here the discussion is not done related to potential energy. With some height and falling down potential energy, just moving body means like that it is moving, they told it is kinetic energy. So half mv square is kinetic energy. So kinetic energy is equal to Q. So in this Q, half is used for increasing the bullet temperature. Heat energy for increasing the bullet temperature means ms delta theta. Ms delta theta. As Q is also equal to half mv square, as Q is also equal to half mv square. So half of half mv square, half of half mv square is equal to ms delta theta. So get cancelled. Delta theta is equal to v square by 4s. Delta theta is equal to v square by 4s. Is it clear or not, better? Is it clear or not? Because Q value is half mv square, so half of half mv square is nothing but ms delta theta. Nothing is there here. Nothing is there to get tensed beta. They only told that, they only told in the question, this is the question page. This is the question page. I will explain. Very simple beta. Just listen. Very simple it is. Bullet going and hitting target. When bullet is target, will heat will develop or not? Just answer the question. Bullet hits the target. Will it produce heat or not? Bullet hits the target. Will it produce heat or not? Yes, it produces heat. Over. So that a bullet, what happened? Work done by bullet. Bullet means moving bullet. Half mv square is equal to q. Half mv square is equal to q. Kinetic energy. Kinetic energy equal to heat energy over. So in this heat energy, how much heat energy produced here? Suppose here some Q energy is produced here. That Q energy is equally shared between bullet and target. Equally shared. So both are getting Q by 2, Q by 2. Both are equally shared. Equally shared. That means bullet is getting how much heat energy? Q by 2. So by taking this heat energy, bullet raises its temperature. Because total heat what produced here is not given only to target or only to bullet. The heat what is produced at Q is shared between bullet and target. Well done. Bullet and target. Bullet and target. So equally shared no beta. How much is shared? Q by 2 is given to bullet. Q by 2 is given to target. That Q by 2 is equal to bullet temperature rise. Bullet temperature rise. This Q by 2 is given to bullet to rise its temperature. So rise its temperature. What is the formula? What is the formula in term of already we discussed in calorimetry? Rise in temperature. Ms delta theta. Ms delta theta. So here m get cancelled. In the place of q I substituted half mv square. Half of half mv square equal to ms delta theta. Already 1 by 2 is there. In the place of q half mv square. Half of half mv square is ms delta theta. Is cancelled. Is cancelled. Delta theta is v square by 4s. V square by 4s. Is it clear beta? So I explained just basic applications. Just basic applications I explained you. You try to solve some problems. You will find some difficulty. So that I will discuss those things and I will clear the things better. Nothing to worry about that. Okay. Now our target of discussion is over related to Joule's law. Why q by 2 equal to ms delta t? One student is asking me why q by t is equal to ms delta t. I already told you that the heat energy what we are providing here, heat energy what we are providing, that is used to increase the temperature. Used to increase the temperature. Heat energy, increasing heat energy formula ms delta theta. So the final formula is delta theta is v square by 4s. From here get cancelled. Delta theta is v square by 4s. V square by 4s. Okay beta. Some students are not there for yesterday means you will feel difficulty of this one. Otherwise nothing is there. Nothing is there. Okay beta. Now let us see. First of all, what do you mean by zeroth law of thermodynamics? Zeroth law of thermodynamics. What do you mean by zeroth law of thermodynamics? Anyone in this world can answer this. zeroth law of thermodynamics माने क्या है बेटा? zeroth law. Yeah, zeroth law. Why they call zeroth law, sir? Actually we are calling zeroth law, first law, second law, like that we have laws. And why they named zeroth law, sir? Instead of that they can give this as first one, this as second one, this as third one, right? But the what happened means before discovering this basic information, some scientist came and directly gave one information, but that's why they called it as the first law. And after that one more scientist gave another information, second law. Then one more scientist gave the other law, but that is basic. This is they have to call third law, but this is basic than these two. This is basic than these two. So they call that as zeroth law. Instead of changing the names of first law, second law, this is the basic law, third law, which was found after these two laws. They named it as zeroth law. Over. Okay, beta. So here you observe here, beta. Here we are taking, not getting. Leave it about that, beta. That is the overaction topic. What I told now. Listen this one. Here what happened means, here this is called as, we are taking total 3 rooms you can find. Total 3 rooms. So this is A, this is B, this is C. So here in this one, this wall what I have taken here, the wall what I have taken, this blue color wala, this wall is called as adiabatic wall. Adiabatic wall or insulating wall. Simply we can call it as insulating wall. Insulating wall or non-conducting wall. One student told me, sir, non-conducting. Yes, you are correct, beta. You are correct. Insulating wall or non-conducting wall. And one more wall, this green color wall is called as conducting wall. Conducting wall. Conducting wall. So what do you mean? This is the difference between insulating wall. Insulating means non-conducting. That means heat cannot transfer from A to B or B to A. No exchange of heat. No exchange of heat between A and B. No exchange of heat between A and B. इधर से ए से बी और बी से ए तक हीट नहीं जा सकता बेटा. ए से बी या बी से ए हीट जाने का इधर नहीं है, इसलिए वो इंसुलेटिंग वॉल बोल रहा है. इंसुलेटिंग माने हीट नॉट फ्लोस, हीट कैन नॉट फ्लो. And here this is the green color is conducting wall. Green color is conducting wall. This green color line is conducting wall. So here heat can exchange between B and C. Heat can flow between B and C. Heat can flow from C and A. But heat cannot flow from A to B. From A to B. In your childhood, if you go through your childhood maths, they used to tell like that. X equal to Y, Z is equal to X. From these two they used to say Z is equal to Y. If you go to your school maths, in very schooling, 5th class, 4th class like that, they used to give information like that. अरे बेटा x इक्वल टू y बोला, इधर इधर z इक्वल टू x, ये x x इक्वल है ना, इसीलिए y z भी इक्वल होना. सो z इक्वल टू y. एक बार स्कूल को गया तो आप फ्लैशबैक में देखा तो ये सब याद आ जाएगा आपको. नाउ कमिंग बैक टू द टॉपिक हियर. So similarly, A is thermal equilibrium with C. A and C are thermal equilibrium. Thermal equilibrium माने क्या बेटा? What do you mean by thermal equilibrium? What do you mean by thermal equilibrium? Yes, same temperature. A and C are in thermal equilibrium. A and C are in thermal equilibrium. Sorry, so A and B, not C. A and B are in thermal equilibrium separately with C. Separately with C. Then A and B are in thermal equilibrium separately with C. Then A and B are also in thermal equilibrium. Very simple and basic definition. Everybody can understand. Nothing secret here. So A और C का सेम टेम्परेचर है बेटा. B and C का भी सेम टेम्परेचर. A और C का और B and C का सेम टेम्परेचर है तो A and B को भी टेम्परेचर सेम ही होता. So A and C same temperature, B and C same temperature, then A and B are also having same temperature. That is zeroth law of first thermodynamics. Zeroth law of thermodynamics. So nothing to get tensed. Everybody understood. I don't want to discuss further this topic. I don't want to go ahead with this topic. I am interested in teaching first law of thermodynamics. I like it like anything. First law of thermodynamics. Let's start the game. First law of thermodynamics. First law of thermodynamics. Then first law of thermodynamics के जाने के पहले मैं ये क्वेश्चन पूछना चाहता हूँ. आपको मैं नहीं सिखाता हूँ पर क्वेश्चन पूछना चाहता हूँ. What do you mean by open system? What do you mean by closed system? What do you mean by isolated system? Isolated. फर्स्ट लॉ जाने के पहले, ये फर्स्ट लॉ में नहीं है बेटा, ये फर्स्ट लॉ में नहीं है. मैं क्वेश्चंस पूछने के बाद फर्स्ट लॉ के बारे में मैं जाता हूं बेटा. ये क्वेश्चन पूछने के बाद. Isolated, open and closed. In open system means both heat and matter exchanges. Both heat and matter exchange with the surroundings. Both heat and matter exchange with the surroundings. That means suppose you are taking some milk and you are heating in a container. So milk will be evaporating. So we can observe the heat and matter both exchange. Closed system. If you keep the cap on the container and you are heating, only heat exchanges, only heat. Inside matter cannot go out because it is closed. Only heat exchanges. Only heat exchange. Here previously both heat and matter. Isolated means, that means what do you mean by isolated? Heat and matter both cannot exchange. Neither heat nor matter. Heat and matter both cannot exchange. Both cannot exchange with the surroundings. Both cannot exchange with the surroundings. Very simple, very simple. So here what happened? Both heat and matter, both heat and open system माने बेटा, heat and matter both will exchange. Closed system means only heat. Isolated means heat and matter both cannot exchange. Like thermoflask. Generally tea will put in flask and will be carrying so that the heat will remain constant and inside the content also will remain constant. Thermoflask is the best example for isolated system. Okay, leave it about this knowledge. I hope you are very good than me also related to this information. So I want to stop giving this information now. Now let us continue this one. Please concentrate here also beta. Give me the opportunity to teach first law of thermodynamics. Here they are telling that whatever the heat we are supplying to the system, that is given to two things. One for change in internal energy and other one for external work. I will explain all these terms in detail. Beta. First you concentrate. Very well. You learnt in chemistry. Well done beta. But here we learn some secrets in solving the problems in more detail. Slowly I will go into deep. Heat energy. dQ is heat energy supplied. du is change in internal energy. Change in internal energy. And dW is external work done. So whatever the heat we are providing, that is used in two ways. One for change in internal energy, other one for doing external work. Heat energy supplied is used to do, is supplied, is given to change in internal energy and also to do external work. Is it clear, beta? Is it clear? So we'll see what is this all the terms. What is dW, what is du, and all. dq, okay, dq means heat energy, everybody knows. Heat energy means either ms delta theta or mlf. Anything we can write that about, leave it about dq. Mainly we have to learn here about du and dw. We have to learn about du and dw. du and dw. du is equal to u final minus u initial. So change in internal energy means final internal energy minus initial internal energy. What is this internal energy? What is this internal energy? Internal energy is just, we can write it as directly proportional to temperature. The temperature of the body corresponding energy, the energy corresponding to the temperature, the energy corresponding to the temperature of the body is called, in simple language, we can call internal energy. In simple way we can say the energy corresponding to temperature. टेम्परेचर के बारे में डिस्कस करने वाले एनर्जी को इंटरनल एनर्जी बोलता है बेटा, इंटरनल एनर्जी बोलता है. U is proportional to T. U is proportional to T. If suppose here, if temperature is increases, temperature increases, what will happen if temperature increases? If temperature increases means then change in internal energy is positive. Du is positive. If temperature increases, कैसा होता है सर? पॉजिटिव. टेम्परेचर इंक्रीज माने final internal energy is greater than initial internal energy. Final internal energy is greater than initial internal energy. Final internal energy is greater than initial internal energy. So final is greater than initial means du is positive. Suppose if temperature decreases, temperature decreases, please concentrate, temperature decreases, final internal energy is less than initial internal energy. फाइनल इनिशियल से कम होगा तो क्या होगा बेटा? फाइनल वैल्यू चेंज ले रहा है अभी, फाइनल माइनस इनिशियल. फाइनल वैल्यू इनिशियल वैल्यू से लेने से कम हो गया तो नेगेटिव वैल्यू आ जाएगा. So here I can write du is negative value. And one more thing, last one, if temperature constant, what will happen if temperature, very important point is temperature constant. Yes, if temperature is constant, what is going to happen? Temperature is constant. Temperature is constant means change in internal energy is equal to 0. Why change in internal energy 0? What is the reason? Because here internal energy is same. U final is equal to U initial. U final is equal to U initial. So change in internal energy of the system is 0 if temperature is constant. I hope you got idea about change in internal energy. For objective point of view, this information is essential. Now, well done. Now let us see the next most beautiful one. Work done. अभी वर्क डन के बारे में देखेंगे बेटा, वर्क डन के बारे में. So what is work done? That is our question here. So to understand, after this work done I will explain. Please concentrate better here nothing. One student is asking me to explain again. Nothing is there here. du is change energy final minus initial energy. Internal energy is proportional to temperature. If temperature is constant, you have to write here not zero. Temperature is constant beta. Zero nahi beta. Temperature is constant. I wrote wrong here. I want to write temperature constant. टेम्परेचर कांस्टेंट. टेम्परेचर कांस्टेंट हो गया तो क्या होगा? फाइनल इंटरनल एनर्जी एंड इनिशियल इंटरनल एनर्जी इज इक्वल. That only I did not get. Well done, beta. No issue at all. Be informing me, beta. Sometimes, due to some hurry or something thinking, sometimes it will become problem. Some mistakes will make. So anything is there. I always accept my mistakes. I will never be like feel for doing mistakes. Sometimes happens. We all are human beings. So if any mistake I make, happily inform me. I will take it very positively, beta. I always like that one. One more thing. I am saying, beta, one thing is clear. After every exam is over, please write error book. One thing is confirmed. How far you wrote exam is not important. You wrote good or not that is not important. After exam you wrote error book or not. Have you got the command on the problems which you didn't do? That is very important, beta. If you can't do that, learning will become no use. So please keep one error book separately. For every exam, you write the exam text date, exam date you write, and write all the errors what you did and what questions you left also you write. Not questions, only answer. Question number, answer. Question, don't write questions again, time waste. Okay, beta. If you got, suppose, if you got in physics, so you got suppose 140 marks in out of 180 in some weekend exam, you are good. Suppose you got 60 marks, myself says you are best. I always says the student is best who got 60 marks compared to 140 marks out of 180. Why like that means the student 140 marks he got means he has only opportunity to learn only 40 marks area. If he got only 60 marks, he has an opportunity to learn nearly how many marks? Yeah, 120 marks he can learn the things with more confidence. How many mistakes you make, that much confidence you will develop. So the students who are getting less in weekend exams means you are lucky. When you will be lucky? When you are going to again rectify your mistakes. If you are not rectifying your mistakes, you are over. I am saying conditions applied. Okay, beta. So now coming back. So always feel that if you didn't get some problem means, yeah, I got opportunity to learn that thing well. I got an opportunity to go in deep about that topic. Always feel proud that you are not getting something means. Okay, beta. But if you don't learn, you are over. Now what happened means we are heating the gas. Here inside gas is there in a cylinder. It is fitted with a piston. This is a beautiful piston. So it is fitted with a piston here and gas is heated. So gas is heated means what will happen? The work is done by the gas on the piston. It pushes the piston up. The piston move up. So the displacement it traveled is dx. So what is the work done formula? Can anybody help me work done formula? Work done is equal to force into displacement, F into dx. फोर्स इंटू डिस्प्लेसमेंट, फोर्स इंटू डिस्प्लेसमेंट। ये ऊपर जा रहा है बेटा, ये ऊपर जाने के लिए फोर्स होता है। फोर्स कहां से आ गया? गैस एक्सपैंड हो रहा है, गैस एक्सपैंड होने से फोर्स बन जाए, फोर्स आता है बेटा। इस फोर्स से क्या होगा? ऊपर गया। सो वर्क डन इज इक्वल टू फोर्स इंटू डी एक्स। सो व्हाट टाइप ऑफ फोर्स इट इज? व्हाट टाइप ऑफ फोर्स इट इज? work done by the gas, it is not on the gas, work done by the gas, गैस से वर्क हुआ। अभी गैस एयर क्या हो गया? एक्सपैंड हुआ, एक्सपैंड होने से ये पिस्टन को, so it is moving up, when piston is moving up, so displacement it traveled is dx, displacement it traveled is dx, and A is called area of cross section of piston. What is A? Area of cross section of piston. Here dx is displacement, displacement of piston. Piston travel from here to here, piston travel from here to here. The displacement is given as dx. Cross sectional area of piston. What is A? A is cross sectional area of piston. Later I will explain about negative and positive. First just concentrate on this one. Later next topic is about negative and positive. Now just concentrate on this one. Cross sectional area. Cross sectional area. Cross sectional area. And here dx is displacement of piston. Cross sectional area of piston. First of all, cross sectional area of piston. Cross sectional area of piston. And dx is displacement of piston. Displacement of piston. Dx is displacement of piston. Nothing to get tensed. Very easy one. Very easy one. Now, what is the force here? This force is applied due to the gas pressure. Due to the gas pressure. So, pressure is equal to force by area. एक गैस प्रेशर एग्जर्ट किया था यार। सो क्रॉस सेक्शनल एरिया ऑफ पिस्टन, क्रॉस सेक्शनल पिस्टन ऐसा होता है बेटा, ये पिस्टन का शेप ऐसा होता है, ऊपर से देखा तो ऐसा होता है। इधर हम साइड व्यू में है, साइड व्यू, ये साइड व्यू बेटा, ये ऊपर से देखा तो ऐसा होता है। सो नाउ हियर फ्रॉम यू आर ऑब्जर्विंग फ्रॉम टॉप, यू आर ऑब्जर्विंग फ्रॉम टॉप, सो दिस इज एरिया, दिस इज एरिया, ओके बेटा। So pressure is equal to force by area. Motorcycle it is present. Yes, well done. Motorcycle it is present. No doubt in that one. What you told is correct. Pressure is equal to force by area. So here what happened beta? In your home you can observe, not exactly piston, not exactly, I am not discussing about piston. So in our house like that cooker will be there. Your top you have cooker whistle. So what will happen when you are heating this one? So the cooker whistle will rise up. Cooker whistle will rise up. So why it is rising up? Why it is rising up? Because of pressure inside. We call, that's why pressure cooker. Pressure cooker. Pressure cooker we are calling it as. Why inside pressure is created? Because of pressure. It will be pushed up. Understood or not better? So pressure cooker we call it as. So pressure is equal to force by area. Yeah, in 800cc car, 3 pistons are there. One student is giving about car information. Yes, but unluckily you are going to become doctor. If you have become mechanical engineer or automobile engineer, it would have been great service to the country. You have very good knowledge about automobiles. Anyhow, doctor you are becoming. Okay beta, let us concentrate on the topic now. Pressure is equal to force by area. Pressure is equal to force by area. So force is equal to pressure into area. Doctor mechanic, very dangerous. If by mistake he think when we go to him, instead of doing that means he got suddenly dream of doing mechanic, that is bike, and you operate with some wrench and anything on us, it is very dangerous. Doctor mechanic means will be very far from you beta. Anything can happen. So force equal to pressure into area. Force equal to pressure into area. So dW is equal to P into A into dx. Okay, beta, please concentrate on this one. P into A into dx. So area into length will give us volume. So this is cross sectional area. This is dx. This part is change in volume. So initially this is initial volume. Please concentrate here, beta. One point I want to say, please concentrate. One point I want to say. This is initial volume. Now what happened? Because of expansion, it went up. It went up like this. So this is final volume. So this middle part means what will happen? This middle part volume is called as change in volume. This middle part is V final minus V initial. So see here, this middle part, from this is the initial volume till here, final volume till here, total final volume. Only this part means change in volume, change in volume. So I can call it as delta V, delta V, delta V. Here we wrote dW, right? So here I can write, well done, dW is equal to P into dV, where dV is equal to what? dV is equal to A into dx, A into dx. So I'm not getting this point. Nothing better. Here, area into length. Nowadays, area into length is called as volume. A into dx is there, no beta. Simply observe like this. A into dx. Send A inside. Send A inside. D into A into x. D into A into x. Area into length is volume. Area into length is volume. So area into length is volume. So I can write dV. I can write dV. Is it clear, beta? Is it clear? एरिया इंटू डी एक्स, एरिया को अंदर भेजो बेटा, एरिया को अंदर भेजा तो एरिया इंटू लेंथ तो वॉल्यूम बन जाएगा बेटा. I hope it is clear. If not still clear, no issue. Just WhatsApp me beta. I will try my level best to clear your doubt. So dW is equal to PdV. dW is equal to PdV. So this is the work done here. Work done is equal to pressure into change in volume. Work done is equal to pressure into change in volume. Now we have to go ahead with this topic. No, here dW is equal to P into dV means V2 minus V1. When P is constant, this formula we can write, simply we can write, instead of dW, directly the change in work done I am calling it as W. Simply change in work done I am calling it as W. W is equal to P into V2 minus V1. W is equal to P into V2 minus V1. No sir, I like dW only. Then you take dW only. No issue. dW is equal to, I can write P dV. There is nothing but P into final volume minus initial volume. So here, if, okay, but well done. Please concentrate. If first case, if gas expands, that means work done by gas. If work done by gas means, what is work done by gas? Work done by gas is called expansion. Expansion is nothing but, what do you mean by expansion? Array, concentrate here. What do you mean by expansion? Final volume is greater than initial volume. Concentrate here. Final volume minus initial volume. Expansion means volume increases. Final volume is greater than initial volume. In this situation, work done is positive. So dW is equal to P into D in this one. Work done is positive, we told. Next one. If work done on the gas, work done on the gas. Yes, please concentrate, please concentrate. Later you can fight with each other, please concentrate. If work done on the gas, work done on the gas, it is called compression. It is called compression. Compression means final volume is less than initial volume. Final value is less than initial value. In this situation, work done is negative. Work done is negative. Work done is negative. Leave about chemistry and concentrate about physics. If volume is constant, volume is constant, volume is constant, what will happen beta? Volume constant हो गया तो volume is constant, work done is equal to 0. Work done is equal to 0. So these are the cases we can observe beta. These are the cases you can observe about work done here. Basic cases. This is about when we have to use these cases when pressure is constant. Pressure is constant. Pressure is constant. You have to use this formula. Okay beta. So now if pressure is variable, leave about chemistry topic, just concentrate what I am telling. In what I am teaching, if you have any doubt, you ask me. In what I am teaching, in that any doubt is there, you ask me, that's all. You leave about chemistry beta now. Now you please concentrate. If so dW is equal to PdV. Sir, but both subjects will confuse us. Nothing confused. There is a difference in the formula in the chemistry and here. That is the reason we have two different ways. I can explain that one later. First you concentrate on this one. Little difference is there. I can show you later. Please concentrate on this one. dW is equal to PdV. If P is variable, it is not constant. P is variable. Pressure is also changing. Then we have to apply both sides integrations. We have to apply both sides integrations when pressure is also varying. Initial volume V1 to final volume V2. So integral dW is W is equal to integral of PdV where V1 and V2. Here P is pressure where is in function of, here pressure is in function of volume. Pressure is in function of volume. It is not constant. Pressure is not constant. Pressure is variable. Whenever pressure is variable, you can't use previous formula dW equal to PdV, you can't use. Pressure is also changing with respect to volume, then we have to use this formula. For objective point of view, it is important. Okay beta? So simply integrate from where to where? From initial volume V1 to final volume V2. dW is equal to PdV, integrating on both sides. Integral dW means total work. This is nothing better, not nothing to get here. First you observe, dW is PdV. P is variable. P is variable with respect to volume. With respect to volume. P is not constant. Then what we can write? Integral dW. Variable means changing. Or we will write here for your more clarity, P is changing with respect to. Pressure is not constant. Changing with respect to volume. When volume is changing, pressure is also changing. When volume is changing, pressure is also changing. Then we can write in this way. Variable you are confused, remove variable term and changing you take. So integral dW is integrating on both sides. From where to where the pressure is changing? From initial volume V1 to final volume V2, the pressure has been changing. So we can't write V1 minus V2 here because pressure function, they have to give something like this. They will give an exam. P is equal to V square plus 2V plus 1, or P is equal to V plus 1, or P is equal to 2V plus 2. Something they will give in exam. Some expression they will give in exam. Then in the place of P, we have to replace that expression. And then we have to integrate. Definitely I will do one sum beta. Now almost the time is end. We'll discuss in the next session one problem I will discuss. No issue. I will do better. I will do one problem in the next session. Now time is almost 12:29. Only 1 minute left. I can't complete the problem. So I am leaving today's class and will continue next class. Thank you beta.